Ladies and gentlemen, today I'll be presenting on physics. On physics today, I'll be discussing on one of the branch of physics called optics. On optics today, I will also be discussing classical physics. On this note, ladies and gentlemen, I was told that optics is a branch of physics that deals with light, its properties, and interaction with matter. And I was also told that classical physics is a branch of physics that deals with the laws of motion, energy, and matter that were developed before modern physics. On this note, ladies and gentlemen, classical physics was also called the Newtonian physics because it was introduced by Sir Isaac Newton, specifically in the year 1687. On this note, ladies and gentlemen, we'll be looking at our problem to solve. On our problem today, our problem is, if in a prism A is 60 degrees and N is equal to 1.52, which is the index of refraction or the refractive index, calculate the minimum deviation of the rate of light that passes through it. Ladies and gentlemen, before solving our problem, we'll be looking at our diagram to solve. On our diagram today, we have the diagram of an angle of a prism. Why it is called the diagram of an angle of a prism? It is called the diagram of an angle of a prism because angle A is formed between two refracting faces of a prism. On this note, ladies and gentlemen, based on our diagram here, we say this is the vertex and this is called the incident ray, and this is also called the emergent ray. On this note, ladies and gentlemen, we'll have A will be equal to 60 degrees and we'll have the index of refraction will be equal to 1.52. Remember, it is specifically in glass. Ladies and gentlemen, why we say this is the vertex? This is the vertex because it is the top sharp point where the two faces meet. And these two faces are called the incident ray and the emergent ray. And the incident ray is where light entering in the prism, while the emergent ray is where the light leaving the prism. On this note, ladies and gentlemen, based on these informations given on our diagram, we'll be using our problem to solve. On our problem, we have data. On our data today, remember we say A, which is the angle of prism, will be equal to 60 degrees, while the index of refraction, which is 1.52. And we also have the minimum deviations, just be equal to question mark. Remember, ladies and gentlemen, A will represent the angle of prism or the refracting angle, while N will represent the refractive index or the index of refraction, while DM will represent the minimum deviation on this note, ladies and gentlemen. I was told that the angle of prism is an angle between the two refractive faces, while the refractive index is the ratio of the speed of the light in a vacuum or air to the speed of the light in a material, while minimum deviations is the smaller angle where the prism then the rate of light. On this note, ladies and gentlemen, and based on this information given, we'll be looking at our problem to solve. On our problem today, we have our formula, and our formula says the index of refraction will be equal to sin parenthesis open dm plus A over 2 parenthesis closes over sin parenthesis open A over 2 parenthesis closes. So we'll be using this formula to solve our problem. Remember, this is the index of refraction or the refractive index. This is one of the trigonometric ratios that were introduced by Hipparchus or sin, and this is the minimum deviations, and this is the angle of prism. On this note, we'll be using this formula to solve our problem. Based on this formula, we say, ladies and gentlemen, we say the index of refraction N will be equal to SRN parenthesis open Dn plus A all over 2 parenthesis closing over SRN parenthesis open A over 2 parenthesis closes. And this will be representing the index of refraction. And the index of refraction is 1.52. So when I see index of refraction, I have 1.52 will just be equal to sin. When I have parenthesis open, when I have the minimum deviations plus A, the angle of pressing, which is automatically 60 degrees. So we have 60 degrees here, parenthesis closes over 2. Over, we have sin, parenthesis open, I see A, and it represents 60 degrees over 2 parenthesis closes. Remember, ladies and gentlemen, we'll be solving our problem based on these information given. We have 1.52 will be representing the index of refractions, will just be equal to sin parenthesis open. Remember, the minimum deviations and the angle of pressing, which is 60 degrees, both of them has the denominator of 2. So we'll be sharing the denominator of 2 with both of them in order to solve our problem. So we have the minimum deviations over 2 plus 60 degrees over 2 parenthesis closes over sin parenthesis open. We have 60 degrees over 2 parenthesis closes. On this note, ladies and gentlemen, we say 1.52 will just be equal to sin. Well, we have parenthesis open. We have the minimum deviations over 2 plus, if we divide 60 degrees by 2, automatically we have 30 degrees, parenthesis closes, over, we have sin, parenthesis open, if we divide 60 degrees by 2, automatically we have 30 degrees. So ladies and gentlemen, based on these information given, we say we have 1.52 will just be equal to sin, parenthesis open, the minimum deviations over 2 plus what we have 30 degrees, parenthesis closes, over sin what we have 30 degrees. Remember, ladies and gentlemen, we'll be looking at our problem to solve. What we have, the refractive index or the index of refraction is 1.52. 1.52 will just be equal to sin parenthesis open. All we have the minimum deviations over 2 plus we have 30 degrees parenthesis closes. All we have the sin of 30 degrees automatically will be 0.5. Remember, this 1.5 will be multiplying 0.5 just to get our answer. So we say 1.52 times 0.5 because what we have sin parenthesis open. We have the minimum deviations over 2 plus what we have 30 degrees parenthesis closes. If I multiply 1.52 times 0.5, automatically I will have 0.76 equal sin parenthesis open. What I have minimum deviations over 2 plus what I have 30 degrees parenthesis closes. On this note, ladies and gentlemen, we'll be breaking this guy in the parenthesis here, while we'll be taking the 0.76 to be served as the sin inverse in order to solve our problem. So we say, in as much, ladies and gentlemen, we say parenthesis open, the minimum deviations over 2 plus what we have 30 degrees parenthesis closes will just be equal to the sin inverse of 0.76. So we say sin inverse parenthesis open 0.76 parenthesis closes just to get our answer. So ladies and gentlemen, we'll be taking this guy from the parenthesis to solve our problem. So we say the minimum deviations over 2 plus what we have 30 degrees will just be equal to the sin inverse of 0.76. Remember, on the scientific calculator, to get our sin inverse of 0.76, we press shift and we also press sin and put the number 0.76, automatically we give our answer. And our specific answer will be 49.46 degrees. So that's what we have. So ladies and gentlemen, sine inverse of 0.76 will give 49.46 degrees. On this note, ladies and gentlemen, I remember refraction first law state that the incident ray, the refracted ray, and normal at the point of incident all lie in the same plane. On this note, ladies and gentlemen, we have our 30 degree is positive, will be going across, and this guy is 30 degree, which is positive. When going across, automatically it become negative. So what we have, the minimum deviations over 2 will just be equal to, we'll bring this guy and the guy will go across. So what we have, the 49.46 degree minus what we have, 30 degree. So the minimum deviations over 2 will just be equal to, if I subtract the 30 degree from 49.46 degree, I will have 19.46 degree. So on this note, ladies and gentlemen, I balance the guy by 1 just to get my minimum deviations to solve my problem. So this kind of this, what this kind of this, I cross multiply. So the minimum deviation times 1 is the minimum deviation, which is the n, will be equal to 2 times the guy times this guy, which is 19.46 degrees. Parentheses and closes. So the minimum deviation will be equal to 2 times 19.46 degrees, and we have 38.92 degrees. Or the minimum deviations on round this guy, I will have 39 degrees. Ladies and gentlemen, I remember one of the greatest physicists today. He was very broad serious. He introduced the refraction second law called the Snell's law, specifically in the year 1621. It was published by one of the greatest physicists or mathematicians today called René Descartes. On this note, ladies and gentlemen, the refraction second law, which is the Snell's law, states that for a given pair of media, the ratio of the sine of the angle of incident to the sine of the angle of refraction is constant. That is the refraction second law called the Snell's law. Ladies and gentlemen, thanks for joining me on this physics journey. Keep practicing, keep pushing limits, stay curious, and let us go to deeper videos. Always remember that physics is a fundamental science that deals with the basic laws of nature. Don't forget to like, share, stay tuned, subscribe, and comment in the comment section. Once again, B. Bomanseh Jr., popularly or commonly known as Sketchy, the all-time record breaker. I thank you.